Boron is an interesting atom. It resides in group 13 on the periodic table. It is a metalloid, where all the others in the group are all metals. Boron is black in appearance. The octet rule. The octet rule isn't really so much a rule, but more a broad commonality throughout molecular chemistry. It states that an atom will tend to either gain, lose, or share another atom's electrons in order to have 8 electrons in its valence shell. There are many significant exceptions to this rule. Boron does not like to follow this famous rule. It comes out of the box with only 3 electrons in its outermost shell, meaning that only 3 pairs form when covalently bonded. This brings it up to 6 electrons, not 8. This defiance of the octet rule does come with a price. This gives rise to some unusual phenomenon, usually involving higher reactivity. For example, diborane, which ignites in air. To compensate for the electron deficiency, many of boron's compounds feature 3-centered, 2-electron bonding. This is when 3 atoms are able to share 1 electron pair. It is by no means exclusive to boron, but due to the inherent electron deficiency, this is a hallmark of boron chemistry. Boron is much more stable in compounds that allow for ligand electron donation to the boron. For example, boric acid. With its 3 valence electrons, boron finds another common use, and that is in borosilicate glass, otherwise known as Pyrex. This is a glass with a low coefficient of thermal expansion, and the reason for this is the boron. Most glass is made primarily of silicon dioxide, small amounts of sodium or other metals, but essentially, it's an amorphous solid consisting of silicon with 4 oxygen atoms bonded to it. Mixed together, the boron cross-links the silicon, and as a result, the glass has increased rigidity. It is this rigidity that is responsible for the low rate of thermal expansion, meaning borosilicate glass won't stress and crack so easily due to rapidly changing thermal gradients. Borosilicate is the common glassware choice for performing chemical reactions because of this property, as well as its transparency.